So good day everyone. My topic for this subject in Abstract Algebra is all about properties of homomorphism. It is prepared by myself. I'm Orland Magsanay Milano, and I hope that you are prepared to listen my video tutorial in your individual and respective seats. Now in my topic, let's going to first in definition. First, let P be a mapping of a set X into a set Y. Let E Cx and B Cy. The image of A under P is in the quantity of P of A is to small letter a is the element of big letter A. Closed quantity. The set P of X is the range of P. The inverse image of P of inverse of B in X is in the quantity of X, element of big letter X, is to P of X, the element of B, closed. So now let's going to our theorem. We have four theorems here. So let P be an homomorphism of a group G into a group G prime. So first theorem, we have P of A is equal to A prime. Second theorem, P of A prime is equal to P of A close inverse where all A is the element of G. Third, if H is a subgroup of G, then P of H is a subgroup of G prime. Number 4, if K prime is a subgroup of G prime, then P inverse of K prime is a subgroup of G. So now let's move on to our proof in our theorem. So number 1 proof of P of A is equal to A prime. Now consider P of A where A is the element of G. We have P of A is equal to P of AE is equal to P of A times P of E. By cancellation law, P of E must equal to the identity or A prime. Number 2 proof. For our theorem, we have proof of P of A inverse is equal to P of A close inverse. So we have P of A times P of A inverse is equal to P of A times A inverse is equal to P of E is equal to E prime or identity. Thus, P of A inverse is equal to P of A close inverse. So now let's going to our proof in the number 3 theorem. So we need to prove that first it is a close. So suppose that A prime B prime is the element of P of H, then there exists A B is an element of H such that P of A is equal to A prime and P of B is equal to B prime. Thus P of A thus A prime B prime is equal to A is equal to P of A times P of B is equal to P of AB. Since H is a subgroup, AB is the element of H. So therefore, A prime B prime is in P of H. So it is a closed. Second, By part 1, let us prove that it is an identity. A prime is equal to P of A is an element of H. P of H. So it is proved by part 1 that this theorem is in the identity. Third, let's prove that it is an inverse. Suppose that A prime is element of P H, then A prime is equal to P of E for some A is element of H. By part B, A prime close inverse is equal to P of A close inverse is equal to P of A inverse close, and thus A prime close inverse is an element of P of H. So let's going to the number 4 theorem. In our proof, we need to show that first it is an closed. So suppose that AB is the element of P inverse of K prime. We have P of A and P of B is element of K prime. Then P of AB is equal to P of A times B of B as an element of K prime. Because P of A and P of B is the element of K prime and K prime is a subgroup of G prime. So it is proved that in in our theorem that it's a closed. Second, let's prove that it is an identity. By part 1, we have P of A is equal to A prime. It's element of K prime. It follows that E is element of P inverse of K prime. Since K prime is subgroup, so it is proved that it is an identity. Third, let's prove that it is an inverse. So let A is the element of B inverse of K prime. We have P of A is the element of K prime. By part 2, P of A inverse close is equal to P of A close inverse. Since K prime is a subgroup, P of A is element of K prime. Implies P of A close inverse is an element of K prime. So that is my last proof in the theorem fourth theorem for my topic. It's all about properties of homomorphism, and I hope that you gain knowledge, not so very full knowledge, but you can get a little bit of knowledge from my video tutorial, and I hope that you use it in your daily life situation. So thank you everyone for listening in my video tutorial, and I hope that you enjoy it watching and listening for my video, even if I'm not very good in English grammar, but I still effort to show that I'm very good in English. Thank you everyone. Bye.